A very wonderful morning, respected sir and respected ma'am. Myself, Rayyan Roshan Sulde, studying in 9th standard from Dardmand Abdullah Mukadam in his school. Now, I would like to introduce you to concept of our model. The main theme is technology and toys, and my sub-theme is environmental concern, and my project topic is production of electricity with the help of seawater. Most of the earth water, 97%, is in the ocean. Seawater has unique properties. It is saline, its freezing point is slightly lower than the fresh water, its density is slightly higher, and its electrical conductivity is much higher, and it is slightly abrasive. In chemistry, electrolysis is a method of separating bonded elements or compound by passing an electric current through them. An ionic compound, in this case salt, is dissolved with an appropriate solvent such as water, so that its ions are available in the liquid. An electric current is applied between a pair of inert electrodes immersed in the liquid. The positively charged electrode is called the cathode and the negatively charged electrode is called the anode. Each electrode attracts the ions which are of the opposite charge. Therefore, the positively charged ions called cations move toward the anode, while the negatively charged ions termed anions move toward the cathode. The energy required to separate and gather them at the respective electrode is provided by an electrical power supply. At the probes, electrons are absorbed or released by the ions, forming a collection of desired element or compound. Faraday's law of electrolysis states that the mass of the substance of electrode during electrolysis is proportional to the number of moles of electron. The quantity of electricity is transferred to that electrode. Now I would like to show you the working of our model. We have developed a battery that takes advantage of difference in salinity between fresh water and seawater to produce electricity. Anywhere fresh water enters the sea, such as river mouth or estuaries, could be a very potential site for a power plant using such a battery. Actually, we have an infinite amount of seawater, but unfortunately, we don't have an infinite amount of fresh water. As an indicator of the battery's potential for producing power, we have calculated that if all the world's rivers were put to use, their batteries could supply about 2 terawatts. That's roughly 13% of world current energy consumption. The battery itself is simple, consisting of 2 electrons, one positive, one negative, immersed in the liquid, containing electrically charged particles or ions. In the water, the ions are sodium and chlorine, the component of ordinary table salt. Initially, the battery is filled with the fresh water and a small electric current is applied to charge it up. Then it is drained and replaced with the seawater. This method typically needs ions to move through a membrane. Those methods also typically use only one type of ion. Why? This will use the both, the sodium as well as the chlorine. We have chosen here magnesium dioxide and the copper for the cathode and the anode. The voltage really depends upon the concentration of the sodium and chlorine ions you have. If you charge it at low voltage in fresh water and then discharge it at high voltage in fresh water, that means you gain energy. The more you put, the more you gain. This cycle can begin again. Thus, the main thing is here, the key thing is here, that you have to change the electrolyte, the liquid present in the battery. Thank you. I hope that you like the project concept of our model. Thank you very much.